Good day, everybody, and once again we're back together. And now looking at the chemistry paper. Now that we've looked at physical science, physics rather. For those of you who haven't subscribed, welcome to our channel, and please just become part of the family. Okay, and for those of you who have actually finished with the exams, the purpose of us just going through this is going to just be to analyze the questions as we are looking at it. I just want to apologize. I am actually recording this whilst there's load shedding, so I'm relying a lot on the just natural light. Okay, because it's a cloudy day today, the video will keep having different shades, but I hope that you'll still be able to understand and just follow the content. Okay, and particularly for those of you who are writing the IEB, as you are preparing for this exam, I know this is going to be very, very, very essential for you. It's going to be helpful because we're going to be revising some concepts that you will need for the upcoming exams. So without any further ado, let's get into it. The last thing, for those of you who might need assistance with mathematics or physical science, you're more than welcome to also email us, and our email address is info@mlungisinkosi.co.za. all right, now let's start with the multiple choice section and look at this paper. So the first question that we have there, okay, 1.1, they say which one of the which formula rather shows the way in which atoms are bonded in a molecule but does not show all the bond lines. Okay, we would know the molecular formula would show all the bond lines, but the condensed structural formula does not. Okay, so our answer to 1.1 there. Okay, so we'll start with that one. So 1.1 is definitely going to be D. Right, moving swiftly for 1.2, which one of the following compounds has hydrogen bonds between its molecules? Now remember that hydrogen bonds, there are two organic compounds that have hydrogen bonds. That's alcohols as well as carboxylic acids. Okay, so if I look at the first one, it's not. The second one is not either. That looks like a ketone. The third one looks like an ester, and definitely it's going to be the last one there, which is D, which does look like an alcohol. And you note in this case how they've actually structured this alcohol is that they have shown the OH, the hydroxide ion. In this case, it's with a bracket there, and it's at carbon number 2. Okay, right, now the third question, 1.3, they say consider the compound below. They say which one of the following is the IUPAC name of this compound? Now if you look at this compound, I can see already that I've got a C double bond O that is actually not at the terminal carbon. It's in the carbons that are sort of in the middle, okay, not the ones at the end. So definitely that would be a ketone there. Okay, but in this case, when I look at this ketone, it's so it's got how many carbons in its parent chain? 1, 2, 3, 4, 5. Okay, so in this case you would say, well, if we had to number, we could number left to right and right to left, not a problem in terms of the functional group. However, we must get the least combination when it comes to, you see there we've got a side chain which is a methyl group, right? So in this case I'm going to number left to right because in this case remember that it's closest, this methyl group is closest to from the left hand side. Okay, so it's going to be 1, 2, 3, 4, 5. So at carbon number 2 I've got a methyl, and this is going to be pent, okay, which is 5, pentan 3 one because it's a ketone. Okay, so it looks like the correct one, 2 methyl pentan 3 one. okay, which is the the suffix for ketones. So it means that 1.3 should be A. Okay, let's look at the other ones. So this one says 4-methyl pentane 3-one. So this would be the case if we had numbered from right to left. Okay, notice this is not a side chain, okay, because it's part of your parent chain. All right, it means that our chain is bent. Okay, so whenever you've got what seems to be a side chain at the end, it's actually part of your parent chain, right? So this would be 5 carbons in our parent chain. I hope that makes sense. So this would be 2-methyl pentane 3-one. So it wouldn't be this one. Definitely not C and D, because it suggests that there's more than one side chain. And in this case, we only had one methyl group. All right, so let's go to the next one, which is our 1.4. Right, 1.4, they give us a 2-gram piece of magnesium that reacts with excess hydrochloric acid according to the following balanced equation. So there's our equation given there. They say which one of the following changes will increase the yield of hydrogen. So we want to know what should be able to increase the yield. It means that the amount of hydrogen that is produced. Okay. Now what you need to keep in mind there is that because magnesium is our limiting reagent. Why am I saying that? Because in this case they told us that hydrochloric acid is in excess, right? So it means what's going to limit the extent of the reaction, or what's going to run out first in that case, is your magnesium. Okay, so as a result, if you add more of that magnesium, you should be able to actually get more hydrogen. Remember, we're talking about the yield and not the rate of reaction in this case. So if I look at those options that we're given, the first one says to crush the magnesium, the piece of magnesium. Well, that will increase the rate of the reaction, but you'd still get the same amount, right? So the yield would be the same. So in this case, they say use a 3-gram piece of magnesium. I'd absolutely agree with that, and I would go with B for that. Okay. So in that case, if you look at this, the third one, use a greater volume of acid. Remember that volume would not necessarily, with the same amount of magnesium, you'd still get the same result in terms of hydrogen. And then the last one, they say use a higher concentration of acid. Well, once again, that will increase the rate of the reaction, but not necessarily give us a higher yield. Okay, right. So I hope that makes sense. So looking at the fifth question, 1.5. They say the Maxwell-Boltzmann distribution curve, that is P, represents the number of molecules against kinetic energy of a certain reaction, right? So before we even look at the options, obviously in this case, you've got a higher peak for Q than you do for P, right? So in that case, you must keep in mind that obviously to get a higher peak like this, that would mean that the temperature for Q is actually less than the temperature for P, right? Actually not. When I think about it, when I look at the average kinetic energy for both P and Q, it looks like both of them have got the same average kinetic energy. However, the number of molecules here at Q should be higher. So they said curve Q is obtained after the following changes, or rather the changes were made to one of the reaction conditions. So this was the first reaction, and in this case they changed one of the conditions to result in Q. And can you see that we've got a higher number of molecules that have the average kinetic energy? All right. So in that case, they say, well, which one of the following changes resulted in curve Q? Okay. Definitely. Let's see. If we said addition of catalyst, that definitely wouldn't be the one, because remember, Once I add a catalyst, what it does is that it decreases the activation energy. It lowers the activation energy. So increase in temperature, no, because if it was an increase in temperature, first of all, it would mean that, you know, I would have a lower peak, but my distribution would actually shift. In that case, more towards my peak would actually move towards the right. Okay, increase in activation energy, that's not the one, definitely. And in this case, they say D, increase in the concentration. So I would go with D, which is the increase in concentration, because obviously if I increase the concentration, there'd be more molecules, you know, that per unit volume, and as a result it would increase the rate of my reaction. Okay, with the same average kinetic energy, by the way. So D would definitely be the one. All right, as we move now towards the next question. The next question says the expression for the equilibrium constant Kc of a hypothetical reaction is given as follows. Okay, and remember that Kc is the molar concentration of our products, so it means that X would be a product and both Y and Z would be our reactants, right? And remember that, you know, the power in this case indicates the coefficient. So if we were to write it down, we know that X should be actually on the right hand side. So X should be on the right, and it would be 3X. And in this case, it means that both Y and Z should be on the left hand side, but you'd have 2Y and Z, okay, on the left hand side. Now that doesn't mean that those would be the only reactants, by the way, because you can have other you know, reactants or even products, but if they are not in gaseous phase or aqueous phase, you would not necessarily include them. So Y, Z and and X would actually have to be in gas form, okay, in gas form or in aqueous form. Okay, so they say which one of the following equations for a reaction at equilibrium matches the above expression. Okay, so let's have a look at something that looks remotely close to what we have. Okay, there's Z and 2Y there, and they are aqueous, and we've got 3X, which is aqueous, and we've got Q, which is solid. So that looks possible. Okay, let's look at why this one wasn't possible. So Z and 2Y, and they are in gaseous phase, but can you see that X is in solid form in that case? So you wouldn't include it in that expression. Okay, and then Z and 2Y, okay, that looks possible. Okay, but 3X is liquid, so you wouldn't include it either. Z and Y2, definitely not the one, because you'd have to have 2Y in order for it to be Y squared. So definitely the correct answer there should be D for 1.6. All right, now let's go to the next one. They say two dilute acids of equal concentrations are added to separate test tubes as shown below. So there it is, you've got two acids there, 100 cubic centimeters of hydrochloric and ethanoic acid respectively. Now they say consider the following statements regarding these acids. Okay, they say the pH of each is less than 7. Definitely both of them are acids, so that would be true. They say both will react at the same rate with 5 grams of magnesium powder. I don't think so, because the concentration of your you know, your hydronium ions in that case would not be the same. Okay, so I would not think that statement 2 is correct. And they say both will neutralize the same number of molecules of sodium hydroxide. And I think that would not be true either, because remember that ethanoic acid is not a strong acid, whereas hydrochloric acid is a strong acid. So this one actually gives, you know, a higher concentration of hydronium ions, whereas this one gives a lower concentration of hydronium ions. So in this case, I think the one statement that looks true is, you know, statement 1. Okay, I stand to be corrected if maybe I've missed something, but I think to my best conviction, I think statement 1 would be correct, and so the answer would be A. All right, let's continue looking at the next question. Right, the next question says, which one of the following is a conjugate base of H2PO4 minus? So remember, in order for it to be a conjugate base, it means that H2PO4 minus has to be an acid. So in this case, when you take H2PO4 minus and it acts as an acid, it means it gives away its H plus. So once it gets rid of an H plus, what does it become? It becomes HPO4 2 minus. Okay, so that would be its conjugate, right? So in this case, it means the conjugate base in that case would be HPO4 2 minus. So the correct answer there should be B. Okay, and 1.9. Okay, so we're given there, and I did say I apologize, you know, because we keep having different shades of the same video. Remember, as I said, I'm experiencing load shedding where I am, so I'm trying to use as much natural light as possible, and obviously because it's a cloudy day, you know, our lighting is inconsistent. Okay, right. So 1.9 says you've got the diagram below represents a voltaic cell. Okay, so they say which one of the following correctly describes the movement of ions in the cell. Okay, so let's see the type of ions. Okay. So in this particular one, so you've got zinc and copper. So if you work this out, you'll realize that zinc is actually undergoing oxidation, and it becomes zinc 2 plus by giving away 2 electrons, and copper is undergoing reduction. So in that case, copper 2 plus rather, plus 2 electrons would actually give us copper, right? So in that case, this would be undergoing reduction. But now we're looking at the ions, and in this case, what's happening is that zinc is becoming zinc 2 plus, and there are more zinc 2 plus ions here, which we call the cation ions, right? The positive ions. So you end up having an excess of cation ions. Okay, and because you've got an excess, now they'll go into the you know, the salt bridge from X, you know, to Y in a sense, and then from the copper sulfate, you've got copper 2 plus ions there, and remember the sulfate ion is 2 minus, right? SO4 2 minus. So they are actually telling you that's copper 2 plus over there. Okay, because you've got only one copper, so it would be 2 plus with 2 minus, and that would form copper sulfate, isn't it? Okay, so now because copper 2 plus ions are now receiving electrons, and now they actually are becoming copper 0, which is in this case solid. Okay, because it's undergoing reduction. So in this case, what happens is you end up having an excess of sulfate ions here, and as a result, they will then go into the salt bridge from Y, you know, to actually react with the positive ions in the salt bridge. Okay, so let's see there. They say type of ions. So definitely I would have zinc 2 plus ions go from X to Y. Okay, and I'll have SO4 2 minus ions go from Y to X. Okay, And in this case, let's see which one would be. So chloride ions going from Y to X. Let's see. So chloride ions are negative, so they would go towards X in order to obviously, so let's say from Y to X in that case. Okay, that looks about correct, but let's check the other ones. SO4 2 minus, we said they are going to go from Y to X, so that would not be correct. Copper 2 plus ions, okay, as I've explained, they would go from X to Y. And potassium ions, in this case, remember they want to bond with the sulfate ions, so they would tend to go towards Y, so it would be from X to Y. So the only one that looks plausible there would be A, which is in this case the chloride ions. Okay, the negative ions in this case would move towards that direction, so that they would actually bond with the zinc 2 plus ions. Okay, I think I'd said copper 2 plus earlier. Yeah, zinc 2 plus ions. So in that case, they would then become, they would react with those, okay, to neutralize. All right, and the very last one, okay, let's just move it a little bit. Okay, so now they say which one of the following statements is true. Okay, so they've given us the diagram below represents a cell that is used for the refining of copper. Okay, so definitely here we are talking purification. Okay, so in this case, remember where we've got the impure copper. Okay, in this case we want to kind of break this one down. All right, so what you do is that you connect this to the positive side of your power supply. In this case, remember that would now become your anode in a sense. Okay, that's where oxidation takes place, and in this case where you want to form the pure copper, that would be your cathode. It would be negatively charged. Okay, and in that case that would become your obviously it would be used in this case to purify that copper there. Now they say which one of the following statements is true. Okay, right, so they say X is made of platinum. Okay, so that would not be true. X should be made of copper, so that ultimately you've got just pure copper over there. All right. The second one says the mass of X increases. That's absolutely correct, because you're forming copper. Remember, in this case you want to form as much copper, pure copper, as possible. All right, so X would increase in mass because remember reduction is taking place there, and we did say it becomes negative. You'd connect it to the negative side, so that the copper 2 plus ions would actually receive those electrons there and actually be reduced, right? Okay, so they say X is the electrode, so that looks correct. B looks correct. Let's look at the next one. They say X is the electrode where oxidation takes place. Definitely not. Remember, in this case we want oxidation to take place here, the loss of electrons, so that this guy becomes copper 2 plus, and then obviously the copper 2 plus ions, copper 2 ions, okay, then in this case would undergo reduction over there at X. And then they say X is connected to the positive terminal of the power supply. Not true. It should be connected to the negative terminal. Okay, so that reduction takes place there. So in that case, the only correct answer would be, which one did we say? We said it's B. Okay, so yeah, and that is how the cookie crumbles when it comes to this multiple choice section. I hope it's been really, really helpful. Yeah, even though we having a bit of an issue with the with our lighting in terms of the sun, but I hope you were able to understand that. Otherwise, ladies and gents, I'll keep dishing out, this good content when it comes to, us analyzing this November 2021 paper. So I do ask that, for those who know of someone, who's in grade 11, going into grade 12 next year, or maybe perhaps who's been thinking of upgrading their results, please just let them know about this channel, so that, they can actually benefit. And that's the reason why we are creating this content, so that we can actually help you as much as we possibly can. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.